Welcome to day 2 of Unit 3. You can put in your planners just day 2, which will be packet page 12 and 13. Remember that has to be uploaded by tomorrow at 5 a.m. You can also be starting the Unit 3 problem set if you haven't done so yet. It's not due till the day before the test. So what I'd like you to do is to pause the video for however long it takes you to do the warm-up. Put those right in your Wednesday box. When you're done, hit play again, and something will pop up so that you can submit your answers to the warm-up. Alright, so for this first one, we have triangle ABC. D is the midpoint, so we know those are the same. E is the midpoint of BC, so we know those are the same. They tell us that DE is 29. Well, we now know that DE is a mid-segment. We want to find the value of x, knowing that AC is 3x plus 7. So the mid-segment is always half of the third side, so we can double the 29 and set it equal to the 3x plus 7. If we had to justify our geometry steps, we would say mid-segment is equal to half of the third side. Simply as that. So we'll have 58 equals 3x plus 7. Subtract the 7 over. You get 51 equals 3x. And dividing by 3, get 17 for x. And just reread the question. X is all that we want to find. So we again have triangle ABC. When you draw a triangle, just label the angles wherever to start, and then we'll label everything from there. D is the midpoint of side AB again. E is the midpoint of side BC. We can connect those to make DE, which is 2x plus 4. And then we have 7x minus 10. So same idea, because our geometry justification would be the mid-segment is half the length of the third side. So you can double the mid-segment and set it equal to the third side that it's parallel to, AC. If we distribute, we would get 4x plus 8 equals 7x minus 10. We could subtract the 4x over and give us 8 equals 3x minus 10. Add the 10 over. That would give us 18 equals 3x. And divide by 3, and we get 6 equals x. Take a second to reread the question. That's all we wanted, was to find the value of x. All right, going to the homework. From our markings in 1A, we can tell that that's a mid-segment there because it's connecting two midpoints. So double the 5x, and it's equal to the 70 because a mid-segment is half of the third side. And you get x is 7. Similar idea for each of the others. You get 23.5 and 2. All right, in 2, they gave us several things. They gave us that this was 80. They gave us that the HD was 80. And they gave us that TV was 100. So HE had to be half of the 80 and VU. That's why we got 40. ED was half of the 100. And those were both mid-segment as half of the third side. And then TE, because that's a midpoint there, they should each be half of the 160 because a midpoint implies two congruent segments. So TE was 80. Now we also have the mid-segment is parallel to the third side, so we get corresponding angles. So this 70 down here gives us this 70 here by corresponding angles. By angles on a line, we get that's 40, meaning this is 40 by corresponding angles. Going on to 4. If we double the 25, it should equal x, because mid-segment is half of the third side. And B, then we get 50 for that x. Double the x to get the 3x minus 6. Double the y to equal 2x plus 1. Both of those mid-segment is half of the third side. Solve the left equation because it only has x. Then sub into the right equation that x equals 6 and go through and find that the y is 6.5. So because we have midpoints, we know we're dealing with a mid-segment. So we can do 2 times the x plus 85 equals the 3x plus 46, and you get your value of x. Well, if PS is x, RP is also x, meaning the whole thing RS would be 248. TQ, they would each be x plus 50s. And x was 124, that's how we get the 174. And TS, just sub in the 124 for x, and we get 418. All right, so that's it for the homework. So we're going to be on packet page 8, if you could turn there. So not all of you might have rulers, but if you were to measure the distance from C to AB, we should be measuring this distance straight down. The distance from a point to any line or line segment is a distance that is perpendicular to what you're looking at. So we wouldn't measure the distance from C to here and say that's the distance from the line. So you always measure at a perpendicular distance. Now I like to think of that like when you're flying in a plane, the pilot comes on and says, we're at a cruising altitude of 30,000 feet above sea level. Well, they're measuring that straight down to the ground, making a right angle. So the distance from the point to a line is defined as the length of the line segment that has endpoints on the point and the line and is perpendicular to that line. So that gray box, you can fill in the word perpendicular. So we have a segment here, and we're going to construct the perpendicular bisector. So with a perpendicular bisector, put your point on one end. And I should say you'll need your compass for this, if you need to pause it and go find it. Open your compass more than halfway, swoop it up and swoop it down, and then we'll reverse where your point was, put your point on the other end point, swoop it up, swoop it down, and then connect those intersections with a line segment. And so what we've just done is we've constructed a line that we know forms a right angle, it's perpendicular, and those two parts are congruent to each other. So what we want to do now is pick any point above the segment on the perpendicular bisector. So let's pick this point right here. And we're going to measure from there to each endpoint. So there's that. Remember, we measure I'm going to have to spin this. We measure with a compass. And mine doesn't let me go in between intervals, but yours would. All right, so we got about that there. Well, if I measure to the other one now, notice I'm not changing the width of my compass at all. And notice it's the exact same length. We could do the same thing with a point below. Say we pick some random point here. Let's measure the distance from that point to the end of the segment. It looks like mine is pretty close to what it was last time. Again, I can't do the in-between values on how my compass opens, but you would be able to. Okay, so if I measure it to the other side now, again, notice it's the same. So the thing we want to notice there is if you are at any point on the perpendicular bisector, you are equidistant from the endpoints of the segment. And if we go to the next page, we'll define that. So this is our perpendicular bisector theorem. If a point is on the perpendicular bisector, the segment, then it is equidistant from the endpoints of that segment. So if it's on the perpendicular bisector, if we connect that to the endpoints of the segment, those would be congruent. When we do this with geometry steps, for this one we will write point on perpendicular. And remember, you can abbreviate that with our perpendicular symbol if you want. Bisector implies equidistant from endpoints. So if we use this fact in finding like a value of x, we would have to do that as our geometry step. Now the reverse of that is also true. If you have a point that is equidistant from the endpoints, then we know that it must be on the perpendicular bisector. So we won't use that one as much, but we could just do the reverse as well. So going to the top of page 10, we've got a picture here, and we've got some segment lengths that are given. So we want to know, how is MT related to AH? Well, notice from point M, it is the same distance to A as it is to H. Well, that is the converse of the perpendicular line theorem we just saw. If you're equidistant from the endpoints, we know that we must be on the perpendicular bisector. So what can we say? How are they related? We can say that MT is the perpendicular bisector of AH. And as always, you can abbreviate perpendicular with our symbol if you would like. So, because we know that, perpendicular, those are congruent. Well, if they're congruent and we know AE is 9, we know EH has to be 9. Well, if this is a perpendicular bisector, we now know that any point on the perpendicular bisector should be the same distance from the endpoints, meaning TH and TA should be the same. So therefore, AT has to be 20. Now, if we had to do our justification for those last two, so 9, we use the converse of our perpendicular bisector theorem. So we would say equidistant from endpoints implies perpendicular bisector. And then for AT, we had point on perpendicular bisector implies equidistant from endpoints. And how far is M away from AH? Well, remember, we need to measure at a perpendicular distance, so we basically need to find this distance here. Well, because it's a right triangle, we can just do a little Pythagorean theorem. we can do x squared plus 9 squared equals 15 squared. That's x squared plus 81 equals 225. Subtract the 81, and we'll get x squared is equal to 144. And take the square root, and we'll get x is 12. So how far is it away? It is 12 away. Now with right triangles, there's these things called Pythagorean triples, and the most common one is 3, 4, 5. 3, 4, 5, if you're doing a right triangle, means 5 has to be the hypotenuse. Well, you could have all those values doubled, tripled, quadrupled, and it would still work. So this triangle we actually are working with here, 9, 12, 15, is actually a 3, 4, 5 triangle where everything was multiplied by 3. 9 is 3 times 3, 12 is 4 times 3, 15 is 5 times 3. So if you recognize that, that can actually save you from having to do Pythagorean theorem. All right, so we have CD as the perpendicular bisector of AB. So let's put our box in there. Let's mark those the same. Well, we know that if you are a point on the perpendicular bisector, you should be equidistant from the endpoints. So we can set up the equation 7x plus 8 equals 5x plus 20. Our justification would be point on perpendicular bisector implies equidistant from endpoint. So now we just have to solve. Let's subtract the 5x from both sides. We'll subtract the 8 from both sides. And we'll divide by 2 to give us x equals 6. And note, that's what they wanted us to find, so we are done with that problem. All right, so one more page for this video. We're going to go to 11. DE is the perpendicular bisector of RA. So let's go ahead and put our box in. It's bisecting, so we know those are the same. They tell us RE is 5x squared plus 2x minus 15. And EA is 3x squared plus 12x plus 33. Well, E is a point on the perpendicular bisector. And we know point on perpendicular bisector implies equidistant from the endpoints. So we can set up an equation. We'll have 5x squared plus 2x minus 15 equals 3x squared plus 12x plus 33. We want to recognize that we have a quadratic, meaning we have x squareds. We have a mixture of x's and x squareds. So we want to get everything on one side so it's equal to 0. We'd like our x squareds to be positive. So it would make sense then to bring everything over to the left, because when we subtract this 3x squared over, it'll give us a positive 2x squared. We can subtract the 12x over. And that'll give us 2x squared minus 10x minus 15 equals 33. And we can subtract the 33 over. And that'll give us 2x squared minus 10x minus 48 equals 0. Well, if possible, we want a 1 in front of the x squared, not a 2. Notice everything is divisible by 2. So we can divide a 2 out of all those, which will give us x squared minus 5x minus 24 equals 0. We want to multiply to negative 24 and add to negative 5. So we've got to think about what are two numbers that multiply to negative 24 and add to negative 5. That would be x minus 8 and x plus 3. We'll set those each equal to 0. We'll add the 8 over to get x equals 8. We'll subtract the 3 over to get x equals negative 3. Now, in our first test of the year, I saw lots of people rejecting negatives. You don't automatically reject a negative. You only reject a negative if it makes a geometry thing negative, so like a side or an angle. Well, notice we want to find RE here. So we're going to take our value of RE and we're going to fill them each in and see what it gives us. We'll have 5 times 8 squared plus 2 times 8 minus 15. If we sub that in, we'll get that RE equals 321. So that's good. Well, let's try subbing the negative 3 in. 5 times negative 3 squared plus 2 times negative 3 minus 15. Now, when you sub it in your calculator, you got to sub it in exactly as it looks. You've got to have the negative 3 in parentheses and then the squared. And that'll end up giving us that RE is equal to 24. So that's good. That's positive. So we can keep that answer. So there's actually two possible answers for this one. You could get 321 or 24. If we had gotten a negative answer, then we would reject it. Okay, but by negative answer, we mean a negative geometry thing, like a segment or an angle. All right, one last one for today. EA is the perpendicular bisector of ER. So ER is getting bisected, meaning that's the congruent stuff, and there's our right angles. Well, we know that B should be equidistant from the endpoints. So we know 2y should be equal to 12 minus 3x. And we also know A should be equidistant from the endpoints. So we have 19 minus 3y equals 5x. And for both of these, we could use the same geometry justification. That point on the perpendicular bisector implies equidistant from endpoints. Now you might be asking, why are we justifying our geometry steps on all of these when it didn't specifically ask? The reason I'm doing it is it's going to ask on your homework. So I wanted to make sure we practiced it a little bit in class. Well, we can now do this with either elimination or substitution. Let's maybe do this in elimination. So we'll get it in elimination form by adding the 3x over. Over here, maybe we'll add the 3y over. So we'll have 3x plus 2y equals 12. Now you can write it as 19 equals the stuff on the right, or you can do the 5x plus 3y equals 19. That's the same thing. We'll do 5x plus 3y equals 19 so that it matches with our stuff down here. And maybe we'll get rid of the y's, so we could multiply this by negative 3 and that by 2, because that would get our y's to be 6 and negative 6. So we're going to have negative 9x minus 6y equals negative 36. And we'll have 10x plus 6y equals 38. And add these together, and we'll just get x equals 2. Let's sub back in to find y. One of the things we had was that 3x plus 2y is 12. So 3 times 2 plus 2y equals 12. That's 6 plus 2y equals 12. Subtract the 6, and we get 2y equals 6. Or in other words, y is equal to 3. But they wanted us to find BR and EA. BR is equal to 12 minus 3 times the 2, which was x. That'll be 12 minus 6, which is 6. EA was 19 minus 3 times our y, so that's a 3 in the y spot. That's 19 minus 9, or in other words, 10. So the big idea, if you're a point on a perpendicular bisector, you are equidistant from the endpoints. So that's it for this video. You now have the assignment to do for your homework and turn it in by 5 a.m. tomorrow.